Hi there, Physics 152. I just want to give you a quick little intro video to Python. You've already been using Python quite a bit in this course, but let me go through a couple of tutorial activities. First of all, let's just start with a comment here. Tutorial 1. These are all from the Computation .physics.u Toronto website, the tutorials. This is part 1. I'm just going to quickly type out this following code. Print hello world, a equals 2, b equals 3. Print a times b is comma a asterisk b. So I can save that. Save as. This goes into some folder and it ends with .py. So Spider likes to save these text files which contain the code as a .py file. And so it's, we're going to replace that. Okay, so now that it's saved, I can run it either by pressing F5 or pressing the triangle button. And it down here in the console window, it gives the output. So it just does what it's told to do. The first thing is it prints hello world. The second thing it does is it assigns to the variable a value of 2. Then it assigns to the variable b a value of 3. And then there's another print statement, and it does a computation of a times b and gives you 6. Okay, next is modules. Modules are Python programs that package together several functions as well as variables for you to access and use. Using modules allows you to extend Python, reuse code, and take advantage of code created by others. So functions and modules can reduce the amount of coding you have to do. So if we were to just type print e and save that, I'll do a Control S and then save that, it would say error, E, not defined. So what we can do is there is a module called Numpy. So before this, in fact even at the very top of this code in line 1, I'm going to type from Numpy import E. When I save that and run it, now it gives 2.718. So this is Euler's number. So E is a variable that is already inside this NumPy module. Another thing we could do, let's from NumPy, instead of E, let's import sine, cos, and pi. And now I'm going to print not E. Oop. I'm going to print cos pi, cos pi over 2, sine pi over 2, and sine of 3 pi over 2. So let's save that, run it, and it's able to do it. So the cosine of pi is -1. Cosine of pi over 2 is, well, it's 0, but notice that Python gives you back something that's kind of close to 0. 6 times 10 to the minus 17, so it doesn't quite work, but you get the idea. Sine of pi is again 0, but it gives you this crazy number. Sine of pi over 2 is 1, and sine of 3 pi over 2 is -1. So good. So that's working. And another thing that you can do, if you just want to take everything, is you can just delete all this from NumPy import asterisk. Now this does not mean multiply, this now means it's a wildcard to just import everything from the NumPy module. And that also works. It gives you a little exclamation point just saying that it doesn't really much like the wildcard, but it definitely works. Okay, so the next activity is about user-defined functions. So I'm going to keep that NumPy because it might come in handy. and I'm now going to put in def, get new activity, open parenthesis, current activity. So the other thing is that this line is running a little long, so I'm going to put a backslash, enter. Anytime you put a backslash and then enter, it just continues that line. So elapsed time, half-life. So this is if you don't want it to run off your little screen here. And then there's colon, and I'm going to put indent, answer equals current activity times 0.5 to the power. So the double asterisk means to the power of elapsed time over half-life. So that's the definition. And then print get new activity 4, 40, and 20. So if I save that, run it, it gives me 1. So what's going on here? So basically this is a new function called get new activity, and all it does is it takes these three numbers, which we're inputting into current activity is 4, elapsed time is 40, and half-life is 20, and it does something in this indent. So this colon tells you what the function is, and anything that's indented by 1, 2, 3, 4 spaces, answer equals, and return answer, that's the part of the function. And so in this case, all it does is it just takes these numbers and puts them into this equation and then returns what's called answer. So that's a nice little way of, if you put that function up at the top, you can use it again and again in your code and save a lot of typing rather than just cutting and pasting that same thing again and again and again. So that could be useful. Okay, next is tutorial 3, parts 2 and 3. This is talking about if and while statements. But in order to understand them, first you have to know that Python is able to understand if something's true or false. So, for example, an inequality like 2 is less than 3, that is going to show up, if we save it, as true. But if you do 2 is greater than 3, and you run that, you get the answer false. Okay, if you get 2 is equal to 3, what do you think that's going to be? It's going to be false. But 2 is equal to 2, and that, and you get true. There's also, I think there's not equal to, so 2 is not equal to 2, and you get false. But if you do 2 is not equal to 3, you get that's true. Okay, so this is a logic test. Okay, so what you can do with a logic test is you can make some kind of an if statement, and if something, if it's true, then it goes and does that stuff. If it's not true, it doesn't do that stuff. So there's an example in the, well, I guess the easiest example would just be to say that if, say, 2 is less than 3, colon, then I would say maybe print that's right. And if I do that, it is less than 3. But if I do if 2 is greater than 3 and run that, I get nothing. Let's do a more, going from the tutorial, do a more complicated program. And this one also has an input statement. So this again is from that tutorial. My integer equals input. Please input your favorite integer. And then it takes that, and then it says if my integer, and the percentage sign is modulo 2, is equal to 0, so double equals sign 0, then that means it's even. So whenever something, an integer modulo 2 is even, or sorry, is 0, that's even. If it's modulo 2 is 1, then it's odd, right? So let's just check that out. if we enter our favorite integer is 42, then your number is even. Okay. So that's how an if statement works. And we'll do a while loop. Let's actually, it's sort of similar. It's while the thing is true, it goes around and repeats the statement. So let's do a countdown. I'll cut this code into here. Okay, so this is a countdown. Current count is equal to 10. Then a while statement. While current count is greater than 0. So what this means is that this will do it. Anything that's in the block down here will happen if this current count is greater than 0. And since 10 is greater than 0, then this is true, so it starts doing it. It'll print it, current count, and then it'll say current count minus equals 1. So that's the same thing as saying this minus equals is to say current count equals the old value of current count minus 1. So this minus equals is a short form for this. So I'll just do it the old way first, save it, and then so it'll just keep repeating that until it's no longer true. And so if we press F5, yeah, there we go. So it does 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Okay, and we can comment out this line and do it shorter by just saying current count minus equals 1. And press F5, blast off. Now if we had done plus equals 1, then we got a problem, right? It's just that it just keeps going and going and going and going. My computer is spinning, so I have to stop the code. Keyboard interrupt. So this is a thing that's pretty easy to do with a while loop, is give it something that's always true, and then it just keeps on going and going forever. So you want to try to be careful not to do that. Okay, so tutorial for part 2 is about lists. So far we have dealt with data values and data variables one at a time, so that each variable can only have one numerical value. So x equals 2. That gives you x is 2. And x equals x plus 1 updates that so it becomes 3. So if we want to do a vector or something, or a list, we call it a list. So I can let's cut and paste. My list equals open square bracket 1, 2, 3, 4, 5. And if I do that, it just prints it out. So it knows about lists when you print it. The other thing that you could do is just select out. Now, if you do my list and then refer to one of the elements in that vector, like it starts with 0 as it turns out. So if I run my list 0, it'll just print out the 1. If I do my list 1, so remember that in Python it starts counting with the number 0. So this is the 0th element, the first element, second, third, and fourth. So if we do my list 4, then it prints out 5. If we do my list 5, what will happen? It'll say out of range, so it doesn't exist. Okay. We can also update one of the parts of the list, one of the elements, by accessing it. If I say my list 0 equals 10, for example, that will reassign it. So if we now print out the list, there now it starts with 10, then 2, 3, 4, 5. And the last part of this tutorial is about the range function. So range is a little weird, but it creates a list. So for example, if I say x equals range 6, and I say for n in x print n, then what it'll do is it'll be the list is 0, 1, 2, 3, 4, and 5. So this is, it's the same as actually putting 0, 6. It creates a list of numbers going from 0 to 6. So do the same thing there. And then what you can also do is you can count by 2s if you want instead of 1s. It assumes a 1 there, so if I do 0, 6, 1, that's again the same thing. But if I want to do like count by 2s, then it'll do 2, 4, and then that it doesn't get to 6. I could also do maybe, let's do 10 and going from 2 to 10 or something like that. And then it'll go 2, 4, 6, 8. Okay, so that's how you use the range function. Okay, tutorial 5, part 1 is about NumPy and NumPy arrays. So right now we've got from NumPy import star. That is not the recommended way to do this. Another way of using NumPy is using import. Import NumPy as NP. So what that does is it imports NumPy and renames it to MP. And then you can use the individual methods and objects as NP. So you could say print NP dot sign of pi, and save that and run it. Oh, dot. I forgot to put the NP dot pi. So you got to put an NP in front of everything, and then again that gives you your 0. Okay. So, and then you can use an array. So array is part of the NumPy package. So if you were to say, for example, a equals np.array, and then assign all these variables and print it, then that is a way of assigning, making arrays. So this just prints all of it. You could instead just print elements 1 to 3 with a little colon, so it'll print all of them. So that'll just do the 10 and the 20 because it's the 0, 1, 1, 2, 3. Interesting. You can also just do a 1. You can do print maybe a squared and run that, and then it actually squares those. So a squared is also an array, but of these values squared. The other thing you can use is called a range. So just sort of like the range function, but now you're doing a NumPy a range. It can go from -5 to 5 in increments of 0.5. So if we print now b, that gives a whole bunch of numbers starting with -5 and going up to 5 in increments of 0. And if we can do, again, we can square that if we want. Oop, not 22. And it'll, that's times 2. That's right. Double asterisk gives you to the power of 2. In which case you get 25 going down to 0 and then up to 25 again. Okay. And last tutorial I'll show you, tutorial 5 part 2, is Matplotlib. So after the import NumPy as NP, you can get a bunch of graphing stuff called PyPlot. So import matplotlib.pyplot as PLT, we could call it, for example. This will make plotting available as the prefix PLT, and NumPy as the prefix NP. So, for example, we could write this code, plt.plot, and show. So this one makes a plot of these two arrays, and this one shows it. So when we press F5 now, this makes, on my screen, a little figure, which you have to find sometimes. Send it somewhere, and this now plots these variable or these numbers that you just put in, which is 1, 2, 3, 4 on the x-axis, and then versus 1, 4, 9, 16 on the y-axis. And of course you can do much more complicated things that they show you, but that's the basic way of making a plot. Okay, and I think that's all. That's the basic Python introduction that you will need before you come to practicals this week.